Now we said that a vector has to have both direction and length. So the direction of this vector from A to B is in this direction. Now the length of the vector we're going to have to work out from its components. So we usually call the length the magnitude. So we can see that the magnitude of this vector by Pythagoras is going to be 3 squared plus the 4 squared, and then we take the square root of it, and that will give this length here, which will be 5. So this will be in effect a 3, 4, 5 triangle. So if we were to write this out mathematically, then we're going to have the vector AB, which in component form is 3, 4. That is, we go along 3 and up 4. So the magnitude of the vector AB, you can see these two lines. This tells us we're looking at the magnitude, and we read this little section here as the magnitude of vector AB. So it's going to equal the square root of the 3 squared plus 4 squared. The square root of 9 plus 16 is the square root of 25, which is 5. So more generally, if we had a vector A, then we can find the magnitude of vector A as the square root of each of the components squared. So let's go ahead and we'll have a look and see how we do this within our assembly language. As in previous videos, we have the calling function on the right and the subroutine on the left. We set aside an array underscore 1, and it's got components 3, 4. We also have the length of the array, which is 2, and we have the position of the result, and we call the result MAG for magnitude, and we set one memory location aside for that using the ds command. We then jump to the subroutine math underscore vect underscore magnitude. So we jump to the subroutine here, it works through, it finds the magnitude, and it returns that value, and it returns the value into mag. And then the program ends. So that's the calling function. Let's have a look at the subroutine. So again, in the subroutine, the first thing we do is some housekeeping. We copy all of the values that are already in the registers that we're going to use onto the stack, so that we can then restore them after we have worked through the subroutine. We then pop the values that are required, so the return address, we pop R2, we pop the next one in the index register, and then the next one in a register R1. Now the first thing we have to do here is clear the contents of register R3. We use register R3 in order to store the intermediate results. So it means that if we were to leave the subroutine and then come back in, it could potentially still maintain a value from the previous call to that function. So we want to make sure that we clear this off and it doesn't corrupt the next time we use the function. So we clear register R3 and we come down and we work through the add array. So we're going to load the contents that are pointed to by register R1 into R0. So that is, we're going to put the array value in. So we're going to put the first one we'll get in will be the value of 3. And then we're going to multiply R0 with R0. So that is, we're going to square it. So we're going to have 3 times 3. And then we leave the result in that at register R0. And then we add that value onto the contents of register R3. So this is why initially we set the register of R3 to a value of 0. We can then increment register R1, that is, we move on to the next value within the array, which will be the value of 4. And we can decrement the index register. So this is the countdown, which tells us how many values we're actually going to have to square. So once we went through the comparison, if the comparison is equal to 0, then we're finished, and then we have to jump to the next part of the code. So the next part of the code is to find the square root of all of those additions, all of those squares. So we jump down to the square root function here, and we've already generated a square root function within the mathematics library. So in this case, we push the value of R3, which is going to contain the 3 squared plus 4 squared, which would be 25, and we have to find the square root of 25. So we pass that value into the square root function. So we jump to subroutine math square root, and then we load, when it returns, we load the result into register R3. We can then jump to return. So we jump down to this point here, and then we can store the result in register R3 in the memory location that's pointed to in register R2, and that memory location is the memory location for the value of the mag. So that means that we're going to have the final square root sitting in the magnitude position within memory. We then go ahead and we restore all the values for the registers, and those are all restored here. And finally we jump to the return address. That is, we jump back up to the calling function, and then the program ends. Of course, when we get down to this point here, if the test hasn't been met and we the value for the index register hasn't counted down to 0 yet, then we jump back up to the array add, and we continue round that loop until that condition has been met, and then we jump to the square root, and we found the square root, and we finish up the program. So I have gone ahead and loaded the subroutine program into the ROM, and also the calling function into the RAM. So let's go ahead and we'll just run this, and we'll run it at full speed here. So this is it running up, and it takes a little bit longer to work through this because the division algorithm always takes a little bit more time. So we can see here some of the numbers. That was the 3 squared, and the 4 squared will be 16, which is the 1 0, and then we add it together, so we got 25, and that's a 1 9 in hex. So we're going through to find the square root of these values of 25, which should be a value of 5, and that's it worked through, and it's cleared off or replaced the original values into all of the registers, and that's it finished. So if I press stop on this, and we will go in and have a look and see exactly where the answer is. So down at 85000, we've got the original vector 3 4, we know it's of length 2, and the final answer is 3 squared plus 4 squared, the square root of that, which is the square root of 25, which is 5. So that's us able to work out the magnitude of our vectors. Let's move on to a different vector function in the next video. Thank you for listening, and goodbye.